So first we're going to right click in the hierarchy, go to 3D objects, and then create a capsule. This is going to be our enemy. Next we're going to add a nav mesh component, and then we're going to create a new script called shooting at enemy script. And then we're just going to open that up in Visual Studio. Once Visual Studio is opened, at the top with all the other namespaces, we're going to add using Unity engine.ai. And this will allow us to reference the nav mesh component that we added. Next, we're going to need a reference to our player's current position, so we're going to create a public transform called player. After this, we're going to need to create a variable that's going to define the size of our enemy's activation range. To do this, we're going to create a public float called activation range. Then we're going to create another public float, and this is going to be our stopping distance. Then a private boolean called isActive. And then we're going to set that equal to false. This will become true once the player has entered the activation range. And then finally, for now, we're just going to create a private nav mesh agent. And we're just going to call this agent. In our start method, we're going to set agent equal to getComponent nav mesh agent. And then we're going to set agent.stoppingDistance equal to our stopping distance. In our update method, we're going to check to see if the distance between the player and the enemy is less than or equal to the activation range. To do this, we can type if vector3.distance player.position transform.position is less than or equal to activation range. If this is true, then we want to set isActive equal to true. Outside of this, we're going to write a statement to check if active is equal to true. And if so, then we want to set agent.set destination equal to player.position. Now we're going to write an if statement to see if the player is within the nav mesh agent stopping radius. So to do that, once again, just if vector3.distance player.position transform.position less than or equal to agent.stopping distance. Then we need to make sure that the enemy is always looking at the player even when it's stopped, as the agent doesn't continue its movement or rotation when fully stationary. To do this, type agent.transform.lookat new vector3 player.position.x transform.position.y player.position.z. Once we've done that, now we need to define a few more variables. So the first one is going to be a private float called time between shots, then a public float called start time between shots, then a public float called start time between shots. These are going to make up a delay between when shots are fired. After this, we're going to need a public game object, and we're going to call this projectile. Then finally, we're going to need a reference to the point that we're going to shoot from. Public transform shot point. Back in our if statement, we want to check if time between shots is less than or equal to 0. If it is, we want to instantiate our projectile at shot point dot position with shot point dot rotation. And then we just want to set time between shots equals start time between shots. And just outside of here, we're going to put else time between shots minus equals time dot delta time. And then just for a bit of convenience, outside of the update method, we're going to type void on draw gizmos gizmos.draw wiresphere from transform.position with the radius of activation range, and then gizmos.color equals color.green. And then we're just going to copy and paste the top gizmos draw wiresphere, and then change the activation range to stopping range. And that's all there is for the script, so save it and then go back into Unity. Now right click in the hierarchy, go to 3D objects, and then we're going to create a sphere, and I'm just going to scale this down to 0.5 by 0.5 by 0.5. And then we're going to just create a new script, and we're going to call this bullet script. Once it's opened in Visual Studio, we're going to need to define a few variables. The first one is a public float called bullet speed. The second is a public float called lifetime. Next, we're just going to create a new method called destroy projectile. And then in here, we're just going to type destroy game object. Back up in our start function, we're going to invoke destroy projectile after lifetime. Then we're going to change our update method to a fixed update method. And then in here, we're just going to type transform.translate vector3.forward times by bullet speed times by time.delta time. That's all there is for the script, so save it and head back into Unity. On a bullet for its speed, I'm going to set this something to like 10, and then its lifetime to something like 5 seconds. Then in the hierarchy, I'm just going to right click, create a 3D object, and just create a cube. This is just going to act as our player. Then I'm going to select our capsule enemy and just drag and drop the cube that we created into the player slot. For the activation range, I'm just going to set this to however big I deem fit, so 10 for me. Then its stopping distance, I'm going to set this to something like 7. Start time between shots, 0.1. And then I'm just going to drag and drop our sphere that we have for our projectile into our asset browser to create a prefab of it. Then back on our shooting enemy, I'm just going to drag and drop this into our projectile slot. And then for the shot point, I'm just going to right click on our capsule, create an empty, and then drag that empty into the shot point slot. And then the last thing we need to do is just go to Window, AI, Navigation, select the object we want, which is going to be our ground, check navigation static, walkable, go over to bake, and hit bake. Now that we've done that, if we go ahead and hit play, we can see that when our player moves into the radius, it will then start to follow us. And then once we get into the activation range to shoot, our enemy will stop and start shooting at us. And then we can move our enemy constantly round and it will always shoot in the direction of our player. If you found this video helpful, please leave a like and subscribe for more game dev content like this. And as always, I'll see y'all later.